Hey, ocean, what's with all the salt? Hi everyone, Julian here for DNews at YouTube Space LA. Recently we got a question from Nene71984 asking why the oceans were salty, and everyone in the office kind of looked at each other and went, yeah, why? Well, I'm going to assume she's not asking why the oceans are all sassy and bitter, but instead is asking why there's salt in the oceans but not in our lakes and streams. Except some lakes like the Great Salt Lake. I know, people in Utah and internet trolls. Jeez. First off, the salt in the oceans is 90% the same chemical makeup as your table salt. Good old NaCl. Sodium chloride isn't the only kind of salt there is. There are many varieties because a salt is just a compound held together by an ionic bond. What happens is an atom steals an electron from another and becomes negatively charged, or an anion. Then it's attracted to the positive cation and the two atoms bond. So a lot of different chemicals can come together and make salts, and because of this, the ocean salt is also made of a little magnesium, calcium, potassium, and a polyatomic anion made of sulfur and 4 oxygens called sulfate. But how does the salt get there? From the rocks on land, actually. According to the US Geological Survey, dissolved CO2 in rainwater makes it slightly acidic, eroding rocks when it falls. That's not the only trick water has up its sleeve, and H2O molecule is polar. The oxygen atom hogs the electrons, so it's more negatively charged on one side and more positively charged by the hydrogen atoms. When salts are in water, they break apart because the only thing holding them in their crystalline shape was that ionic attraction. Once the rain lands, it flows downhill, carrying the dissolved minerals and ions to streams and lakes and rivers, and eventually, the ocean. The USGS also points out salt comes from inside the ocean too. Volcanoes and hydrothermal vents heat water so it can dissolve some of the basalt on the ocean floor, adding salt to the mix. But why does the ocean stay salty? Because salt has been accumulating there faster than it leaves. Some organisms use the salt, or the basalt on the ocean floor takes some back, but the exchange rate isn't even. There's also the factor of evaporation. When water evaporates, the molecules spread farther apart and the magnetic pull from the vapor isn't enough to bring the ions with them. As a result, the salt stays behind and it rains fresh water. So long as the water doesn't get stuck inland, a la the Great Salt Lake, salinity levels will stay below 0.05% compared to the 3.5% average salinity of the oceans. So there's lots of water up here on the surface, but it turns out there might be plenty more hundreds of miles below. Dr. Karen Bondar guest hosts this episode of DNews explaining.
It's long been speculated that water is trapped in the transition zone, or the area between the upper and the lower mantle layers of our planet, and scientists have actually been looking for it for decades.
This video was made because of a viewer question. We read them, we store them, we pick the ones we want to tackle that interest us or that we think you'll like. Keep sending them our way in the comments or on Facebook and Twitter at DNews, and I'll see y'all next time.